So the first thing we do want to ask is about ionic versus covalent bonds. So I just want to know some things about both of them. The first thing I want to know is when we create bonds, how many valence electrons are we trying to get to in all of our elements?
8.
8, perfect. We always want to try and get to 8 valence electrons, which means that which group of elements doesn't want to create a bond?
Noble gases?
The noble gases, perfect, because they already have their full valence shell. They already have their 8 valence electrons, so they don't want any more. They don't want to get rid of any, so they don't want to create bonds with other elements. Ionic compounds. What happens in an ionic compound or an ionic bond? What happens to our electrons?
To trade valence electron?
Perfect. There's a trade or a transfer of valence electrons from one set of elements to another set of elements. And in these ionic bonds, what two types of elements do we have?
Cations and anions?
Awesome. We have cations and anions. And then if we're thinking about just general types of elements from the periodic table, we have metals, nonmetals, and metalloids. What two types from there are a part of an ionic bond?
Metals.
And
transition metals?
Not just the metals.
Metals and nonmetals.
Metals and nonmetals. So we have metals and we have nonmetals in ionic bonds, and the metals are going to transfer their electrons to the nonmetals, creating ions, an anion for the nonmetal and a cation for its metal. So we're transferring our electrons from the anion or the cations to the anions, or the metals to the nonmetals. And then covalent bonds. What happens to our electrons in covalent bonds?
They share electrons?
Exactly. They're going to share their valence electrons so they can both add up to 8 valence electrons, because both of them have more than 4, which means they both want to hold on to all their electrons. They don't want to lose any. So they're going to share their valence electrons so they can both have 8. And what type of element then do we have in covalent bonds?
Metals and nonmetals?
They're just nonmetals. Perfect. So we have just 2 types of nonmetals. They can be the same nonmetal. They can be different nonmetals sharing their valence electrons. So to recap, we have that all elements bond to form, because they want to create 8 valence electrons. And noble gases already have 8 valence electrons, so they don't want to bond with anybody else because they already have their full valence shell. In ionic bonds, we create ions because there's a transfer of electrons from the metals or cations to the nonmetals or the anions. In covalent bonds, there's a sharing of valence electrons between 2 nonmetals. What I want to do now is to actually go through and refresh our brains about some covalent bond practice. So if you guys open up the covalent bond practice assignment for today, we're going to go through the first 2 of them together. We'll start with fluorine. So it says draw the Lewis dot structures for F2, which means we have 2 fluorines that we need for this covalent bond. So what I want us to do first is to draw our Lewis dot structures for each of our fluorine atoms. So how do I draw a Lewis dot structure for a fluorine atom?
Symbol letter, and then the valence electrons around it.
Perfect. Their element symbol with their number of valence electrons around it. How many valence electrons does fluorine have?
7.
It has 7. Perfect. So we go 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. And how many bonds does my fluorine want to create?
2 bonds.
How many bonds does my fluorine want to create? Just one.
1.
How many?
One.
One bond, because it wants this one unpaired electron to create a bond, because these ones right here are paired and they don't want any more on their side. So we have one bond between this fluorine, and so that means the same thing on the other one. One bond, because the rest of them are paired together. And so to show that they're going to share their electrons, what do we have to do?
A circle around them.
We're going to circle the two that are going to be shared to show that we're going to create a bond between those two valence electrons. Now, when we create that bond, how do we show that there was a bond created between those two fluorines? What do I replace that circle with the two valence electrons? What do I replace it with?
Dash.
A dash, perfect. We're going to put a line or a dash between those two, and that signifies that there are two electrons being shared. Am I done?
Then you have to draw the pairs around each other.
You got to add the pairs back onto fluorines. So these have 6 electrons left, because we remember we need to be able to count to a total of 8 valence electrons on all of our elements. So if we count, we have 6 unbonded electrons or lone pairs, and then the 2 being shared between our fluorines. Any questions on this one?
So would you put the extra 2 in the Lewis dot structure?
So this dash right here represents that there are 2 electrons. So if we count them, we have 1, 2, 3, 4, 5, 6, 7, and 8 for this fluorine. And then if we count for the other fluorine, we have 1, 2, 3, 4, 5, 6, 7, 8. So the 2 that are in that line are just automatically counted for both of our fluorines now.
Okay, that makes sense. But what if like there's more than 2 electrons being shared, like there's a bigger number? Will you still use the dash?
So you use a dash, but if there's more than 2 electrons being shared, so if you have 4 electrons being shared, your dash would just become 2 dashes. So every line represents 2 electrons. And so you'll have up to 3 different types of bonds. You can have a single bond, which is 1 pair of electrons, so 2 electrons being shared. A double bond, which is 2 lines, meaning 4 electrons are being shared. Or a triple bond, which is 3 lines, which means that there are 6 electrons being shared.
Oh, okay, that makes sense.
Awesome. Any other questions on that one? All right, let's try one more as a class before I let you work on your own. So we have nitrogen and chlorine. So we have nitrogen and chlorine. How do I draw the Lewis dot structure for nitrogen? How many valence electrons does it have?
6.
Careful, not quite 6.
5.
5. There we go. So we're going to put our 1, 2, 3, 4, 5 on nitrogen. And then chlorine. How many valence electrons does each chlorine element have?
7.
It has 7. So 1, 2, 3, 4, 5. And if we look at our nitrogen, how many bonds does that nitrogen element want to create?
Three bonds.
It wants 3 because it has 3 unpaired electrons. In our chlorines, how many bonds does each chlorine want to create?
1 bond.
1 bond because it has 1 unpaired electron. So which one of our elements is going to be our central atom, the one that all of our elements bond to?
Nitrogen.
Nitrogen, it has more bonds it needs to create. So it's going to be our central atom, or we're going to bond all chlorines to our nitrogen. So we're going to make circles around each of our pair of electrons being shared. All right. So now if I redraw this, I have one nitrogen in the middle. I'm going to have 3 chlorines, one coming out of each side. Am I done?
Now put the other bonds.
Got to bring
Yeah.
the rest of the lone pairs back on. So 2 on nitrogen and 6 on my chlorines. Now am I done?
Wait, so how many are being shared?
So this one is 2 electrons shared. This one is 2 electrons shared. And that one is 2 electrons shared.
But don't we need to like share 3?
What do you mean share 3?
Because that's why the 3 is there, or no?
So that means that there are 3 chlorines. So 3 Cls, which are these right here.
Mm-hmm.
And then we just need to count to make sure we have the correct number of valence electrons, either on or shared between that element. So if we look at this chlorine right here, how many valence electrons does it have, including its 2 that it's sharing?
8.
What about this chlorine
8.
and this chlorine?
8. So they all have like the right amount of valence electrons.
Yep, and we have to check nitrogen. So let's check nitrogen. How many does that one have?
2, 8.
It has 8. It's sharing 6 of them, but it has a total of 8 still.
Okay, that makes sense.
Any other questions about this?
The way that you put it, is that how like we're supposed to put it? Like for example, if there was like 4 chlorines, we would put one on top, like one on each side of it.
I do that because it's because technically that's the right way. If you don't, if you put them all coming off of one side like this, you have your nitrogen and your 3 like that, like that's fine. It's okay any way you have it. I just do that especially so I can spread them apart and so I can keep each one separate a little bit more. But however you draw it, as long as you show that there's one bond between each chlorine and the nitrogen, and you put all those extra valence electrons back on the nitrogen, you're fine any way you draw it as long as everything is shown correctly.
Oh, okay.
Any other questions, comments, or concerns about this, about either of them, or about ionic and covalent bonds in general? All right, then you have 6 more problems to try on your own, and there's a check for understanding on if you can identify ionic bonds versus covalent bonds, because tomorrow on your formative, you should be able to identify if the bond is an ionic bond or a covalent bond before you draw them. If you have no questions about this or about anything else and you want to leave, you are good to go. If you want to stay to ask more questions later, I'm also fine with that.
I have a question.
Yeah, yeah.
For the ionic bonds, what would it look like? Would it look like this? Like, because you said we need to know the difference between what they look like.
So the ionic bonds are between, let me actually do it below. I'll run out of room. Ionic is a metal. Oh, press the wrong button. And a non-metal. Which all of these are non-metals up here. So a metal and a non-metal. So you're going to be creating those ions. So let's say we have, let's go with magnesium. You too. And chlorine. So magnesium, do you know how many valence electrons magnesium has?
No, not off the top of my head.
Right. So we look at our periodic table. Magnesium is over here.
2.
2, good. So we're going to put 2 valence electrons on magnesium. And chlorine, how many did chlorine have?
And 1, 2, 6,
Not 6. Keep going. One more.
7.
7. There we go. So we're going to put our 7 valence electrons on chlorine. And so remember that ionic bonds transfer their electrons from the metal to the nonmetal.
Oh yeah, we did this.
That's what we did last week towards the beginning of the week when we got rid of those electrons from the metal and we had to get to 0 over here.
Mm-hmm.
And we had to get to 8 over here. And so we kept adding more either metals or it kept adding more nonmetals until both of them got to 0 and 8. So for this one, will we add more nonmetals or we add more metals?
We would add more metals.
Careful, the metals are on this side, nonmetals are over here.
Oh, we would add more non-metals.
Exactly. We'd add another nonmetal or another chlorine so that our electron could be transferred over to the other side.
Okay. So, that makes sense. Yeah, we did that last week.
Yep.
So how do we know which one is like which, like for metals and non-metals?
So the metals versus nonmetals is going to be this stair step right here. Do you see where that blue line is?
Mm-hmm.
Anything on the left side is going to be a metal, which is basically the entire first column, everything in the middle and everything up until that blue line. All metals. The only exception is that hydrogen's a non-metal. It technically belongs on that side.